Richard Rashid, but most people referred to me as Rick. In fact, my Microsoft badge said Rick Rashid on it. And the I was at Microsoft. I technically started on September 1st of 1991. And then I stayed until my 65th, a little bit after my 65th birthday. So end of October in 2016 or something like that. And I came in, I was recruited originally to basically be the first director to found Microsoft Research. I was born in Iowa, a little town called Fort Madison in the southeast corner of the state. It was a small town. I grew up there. I lived there till I was 18. The funny thing is that, growing up, the thing I really wanted to be primarily was an astronaut, right? I was very much interested in science, and I loved building things. I just loved, building electronic things, taking things apart, putting things back together again. And so that was kind of the environment I grew up in, but very small town. My parents didn't go to college, so I was really the first person in my immediate family to go to college. In fact, my parents really didn't know very much about what I did. I went to Stanford, and that was kind of a unusual thing for somebody from a small town in Iowa. I was in the math honors program there. I was going to go on to graduate school in mathematics, but then but I also took all the computer science courses there were. I mean, keeping in mind that computer science wasn't a degree program back then, right? So it was the very early days. And but I took a lot of computer science courses, and a professor there, Jerome Feldman, who was the associate director of the AI lab, was decided that he was going to start a new computer science department at the University of Rochester in Rochester, New York. And so he knew about me from my activities there. He contacted me and convinced me that no, I didn't really want to do mathematics. I wanted to go to grad school in computer science. My parents had no idea what that was. And in fact, years later, when my dad was dying of cancer, he started telling me all these stories about things that he never told me when he was, otherwise doing well. And he said, look, when you told us you were going to go do graduate school in computer science, we thought this was the dumbest idea you'd ever had in your life. I mean, we had, this didn't seem like a sensible thing to be doing. They'd never heard of a computer. They'd never seen a computer. And he said, my mom evidently cried all night. I mean, they were super supportive on the phone call. Okay. I mean, they were great parents, but they had really serious doubts about whether this was going to work or not. And then I went on to take the next class, which was a computer architecture class. And there, Stanford had access to some very early HP mini computers, or what we would now call a mini computer. Very early, very primitive stuff. I mean, the way you booted the machine up, so you had to key in instructions on the console, right? So it was very primitive. But I took this class, and I remember writing a program that would read from a paper tape, sort a bunch of sentences, and then print them out on a old printer. And the first time I got that working, I think it was close to midnight. It was the most exciting thing to me, because my intellect had animated this otherwise inanimate piece of hardware, right? Something I thought of, caused this machine to do something. And it was just, I don't know why, it was just really, really exciting to me. I can remember going back to my dorm room, and I was like, I think I was floating. I mean, it was so much fun. And so from that, I went on to basically take all the computer science I could at Stanford. And when Jerome Feldman came to me and said, "Yeah, I'm going to start this new department." And so I went to Rochester because of a relationship that Jerry had with um, with people at Xerox PARC, and also the relationship that the University of Rochester had with Xerox because they were in the same city, and they had a lot of the same people on each other's boards and so forth. We were the first place outside of Xerox to have the Xerox Alto. These were early days of computer science, so there were so many things that we could experiment with. We were also one of the universities that was able to get access to the ARPANET, but again, we were, relatively small department, didn't have a lot of money. And so, we wound up, I wound up having to actually design and build, the boards for interfacing the ARPANET to our computer network, our Ethernet computer network. So it was fun. We built games. I built one of the very first network computer games called Alto Trek. It became sufficiently famous for that when I was hired at Microsoft, uh, in the New York Times article about me, it referenced the fact that I was one of the people who built Alto Trek. So I thought that was particularly funny. From graduate school, I went on to become a professor at Carnegie Mellon University in Pittsburgh, and I created something called the Mach operating system, MACH. And this was a operating system kernel concept where you could build other kinds of systems on top of that. And that became extremely influential in a variety of different settings. So it became the core kernel for what became Mac OS, right? So if you use a Mac product, an Apple product, an iPhone or Mac OS, computer, or if you're using an Apple Watch or even the Apple Vision stuff, you're actually using code that I wrote back in the 1980s. It became important to Microsoft. I mean, the concepts that we had in Mach got adopted within the context of Windows NT, in the sense of this notion of having a multi-personality operating system. That became one of the things that Windows NT was advertised as. And of course, it also had influence on versions of Unix. So pretty much, Windows, Unix, Mac, you're probably using something that either was influenced by or that I personally wrote. And if you asked me back in the early 1980s if did I realize that what I was doing at that point was someday going to be running on a cell phone, I would have said, what's a cell phone, right? I mean, you're influencing all these things in the long future. They didn't even exist back then. Yeah, it is interesting to think about your work that you do early on. I think because I was working in the very early days of computer science, and developing early operating systems and games and networking technologies, that it had probably an outsized influence because it just got baked into the bottom of everything. The list of people who Nathan and Gordon Bell had in their minds to run Microsoft Research, I don't know what that list was. I do know that sort of my first connection to all of this came while I was cooking dinner at home. This is in Pittsburgh. I was a professor of computer science at Carnegie Mellon at the time, and I get this call from Gordon Bell. I wasn't particularly convinced at this idea of Microsoft creating a computer science research organization because I knew how hard that was to do, and I wasn't sure that a small company like Microsoft would be capable of doing it or even really understood what it meant. But I listened to Gordon. He convinced me to have him and Nathan come to my office, and talk to me more about it. So they did do that. And again, he didn't quite convince me at the time, but they convinced me enough that they, will come out to visit us, right? Come out to see us, see Microsoft. So I went to Microsoft, and I met with Nathan. Of course, I met with many of the Microsoft executives at the time. Um, you know, the and I was incredibly impressed with the people I met. I mean, one of the things I think in those days at Microsoft, it everybody was just amazingly smart. I sort of went in thinking, okay, Bill doesn't really probably understand what we're really talking about doing for a computer science research organization. But really, no. I mean, pretty much every part of the conversation I had with him, he and I were very much in sync on what this meant, what would need to be done, how we need to be built, how it would be organized. I was just blown away. All that being said, I went back to Pittsburgh, and I still told Nathan no. And the reason was because I had a lot of loyalty to Carnegie Mellon. And I built up a large research group there, doing the mock operating system and all the things that went around with that. And I just felt sort of an obligation to the people that had brought me into the department and supported me. And then it became even more complicated because they were in the process of turning computer science department into a school of computer science, and they wanted me to be the dean of the school. And so then I wound up with like two different new opportunities. Should I be, dean of this new computer science department, or should I, start this computer science research organization at Microsoft? And during this time, Nathan just kept, coming back and coming back. And my understanding was internally, Nathan would refer to me as Dr. No, because I kept telling him no. But he's really, if you've met Nathan, and you may have, he's not one to really take no for an answer, right? So he would keep trying. And it got to a point where there was a particular day that I said, look, I'm just going to make a decision. And it sort of wound up being, I realized that part of the reason I wanted to stay at Carnegie Mellon had a kind of a guilt component to it, right? Because I would feel guilty if I left, because there other people were depending on me. And I thought, this Microsoft thing, it could be a lot of fun, right? And I sort of so there's guilt here and there's fun here, right? And which should I do, right? And for people who know me, I'm way more of a fun person than I am a guilt person. And so I said, look, I'll do the Microsoft thing. That's the day I told Nathan I was joining Microsoft, and that's the date by which we begin the history of Microsoft Research. Back in 1991, when we started Microsoft Research, really there was no other. Software companies tended to be fairly small, and you to the extent that you had, computer science research labs, they were primarily associated with hardware companies or companies, like AT&T Bell Labs, right? Where they were established companies with large incomes that were very stable, and they believed they could make those kinds of investments. The idea that a small kind of startup kind of software company would be willing to make that kind of investment was really kind of unheard of. And even more to the point, the approach that I chose to take, and that we took in Microsoft Research, was one of doing fundamental basic research, push forward the frontiers of knowledge in the areas that we do research. And there was nothing about that said anything about Microsoft or even any practical use. The goal was we really needed to push the state of the art and move things forward. And my belief was that unless we were doing that, we would not ultimately be that valuable to Microsoft. I mean, in a sense, the notion here was we needed to create things that were going to be a real long-term value that could help sustain the organization in periods when it needed new ideas and new technologies and people who were capable of pushing the company in a new direction. The second part of our mission statement was once we developed an idea or created a technology, to work as hard as we could to move that technology into use, into product. And so, but that was really the second step. It didn't impact what we worked on. It's like if something made sense, then we would put all of our energies into trying to make sure that it really did have an impact. And the last part was really to ensure that Microsoft and really, our society really had a future. Because if you think about the role of basic research, it's kind of like an insurance policy for the future. That's the value to a company like Microsoft. And if you look at our software competitors in those days, they're almost all gone, or they're irrelevant, whatever that means. They didn't make those kinds of investments. I mean, they didn't adapt, they didn't change. And I think the thing about Microsoft that I think has been probably its greatest asset over the years is this willingness to keep looking around and saying, what's changing in the world? How do we adapt? How do we lead in new areas? How do we adapt to change when we have to? And a lot of organizations, a lot of companies, a lot of people are not willing to do that. We needed to make sure that we were getting the best possible people. And, the people we were recruiting against were universities and some of the other labs that existed, Bell Labs, IBM research. Another aspect was making sure that we had the right kind of environment for working with the product organization. And so one of the first things we did was to create a team, a program management team, that would actually sort of work with researchers, but also work with parts of the product organizations to try to bring the ideas of one to the other and make sure the researchers understood what was going on in the product organization, what issues they were confronting, what problems they were dealing with, what opportunities there might be for new ideas. But that the product organizations also had a conduit for the ideas from the researchers. And I think that was kind of an important component, again, of those early days of trying to say, how do we make sure that we do have that impact? How do we train our researchers to understand the product organization, what the product cycle is, when it makes sense to work with the product team, and when it frankly doesn't? One of the things I did was to establish this notion that if a researcher wanted to go work within a product team, that they would not be punished for that, meaning they always had a golden ticket to come back, and that was always available to them, and that was important because in many cases the best way for ideas to bridge a gap is with people, right? Is for the people who understand them and know them to work with them. I mean, when we first started, the simple example, when we first started this idea that we would develop our own search engine at Microsoft, I sat down with the guy who was starting up the product team there, and he basically said, "Look, I want a list of your guys who know how to do this, your people, and these are mine, and we're going to put them in their own space, working together." And it wasn't just about search; it was also about building the server infrastructure and the technologies that would let you run things at scale, right? So a lot of people think, oh, it's just about building a search engine. No, it's not. It's about building an entire infrastructure that can take, billions of requests and get back to you right away, right? So there's a lot to it. And so we had people that were in our systems organization, database people, people that were in inferencing technologies and search technologies, all working with the product team. And again, everybody knew that this was all hands on deck to get something to happen. But when it was done, the researchers, if they wanted to stay there, great. If they wanted to come back to research, they always could. And I think this notion that that we would work as hard as the product teams to help realize their goals was something kind of ingrained from the very early days of Microsoft. If you're only investing in things that are going to pay off, then you're going to be missing the most important opportunities. So again, you make these investments well ahead of when they're going to be valuable. So we had built up one of the strongest basic research groups in computer graphics. And I think it was the 1996 SIGGRAPH being the most important, computer graphics conference. And in that year, more than 25% of all the papers in the conference had a Microsoft research author. And I can remember, this has never been done before, right? This is like extremely unusual to have, a single research lab have that kind of influence on one of the top conferences. And I remember going into Nathan Myhrvold's office at the time, and I'm sure we were thinking exactly the same thing because we both had gotten this news, and we just looked at each other and just started laughing. It's like, we'd made it, right? This was a coming out party for Microsoft research because people realized, like, here's this research lab. It's only been going for 5 years, right? And yet they're suddenly having this big impact in this conference. And then you start to see other conferences, other major conferences in other areas having, 15, 20, 25%, Microsoft research authors. It's like, who are these guys, right? But there was that was a point in time where it became clear that Microsoft Research had become a significant player, in the research world. It was also a point where we started to expand in a fairly significant way. So, we'd grown, fairly steadily, over that period, but not huge. We weren't a particularly huge organization. I think we maybe had 100 researchers. And I remember, then going back to the impact we had on the release of Windows 95 and Office and so forth. Bill sent me an email, basically saying, okay, you guys are doing great. I want you to triple the size of research. Now, I think Bill may have been thinking more in terms of how product groups work, because you could grow a product group fairly quickly, right? You can't grow a research group that fast, right? It takes way longer. But, I said, look, Bill, I can't do it that quickly, but we can grow and we will grow. And that's when we also started making investments outside the United States, because there was a limit on the amount of talent we could access just within the United States in any given year. But we started our research lab in Europe, in Cambridge, England. We started a research lab, another year later or so in China, in Beijing, Microsoft Research Asia, and so now we were able to geographically expand, right? And we could bring in many more researchers from new areas of the world. So we could tap into people who really wanted to be in England or in Europe. We could tap into the Chinese young Chinese researchers. We could and then, after that, we eventually started a lab in India. So we started growing, but not just within the US, we grew broadly. And again, that allowed us to bring in a lot more talent than we would if we'd only confined ourselves to the United States. One of the things that I am rather proud of is something I mentioned earlier, which is the work that we eventually did to advance speech-to-speech machine translation. I'd come up with this feeling like I needed to do something to try to help stimulate people to really push the state of the art. And I thought, we should just be doing more. Give people license to do really out there kinds of research projects. And so I came up with this notion of the Impossible Things Initiative. And the idea was, I had this memo and I sent it around. The idea was that it goes back to the Lewis Carroll's, impossible things before breakfast, right? That we should look at some things that, in some sense you could say at that instant in time were impossible, but that, could be, a stimulus for ideas that could have an impact later on. And one of the few that I spent some time writing about in that memo was the idea of doing this speech-to-speech translation. And I said, look, every year I go to China as part of our 21st century conference that we'd run for, tens of thousands of Chinese students each year. And I'd get up on stage, I would give my speech, but there would be translators, human translators in the back that would do the translations. And what if I could get up there and give my speech and have a computer system do the translation? And to do that, as I'm speaking, so that people could hear me speak, in Chinese. And at the time, that really seemed very far from possible. After I sent that memo out, one of the things I would do, is I would have lunch with various teams of researchers in their cafeteria. And I would mostly I'd go in the cafeteria, I'd just sit down with groups of people, and we just talk. And that particular day, I happened to sit down with the speech recognition team. And, I remember, one of the young researchers was basically just haranguing me and saying, look, this is not possible. I mean, the rate of progress in speech recognition has been just, turtle slow, for the last 15 to 20 years. And, what you're talking about isn't going to happen for more than a decade. And I kept giving, suggestions. Well, I'm a really, when I speak in public, especially when I speak in a foreign country, I speak very methodically. I'm from Iowa, so I have a fairly nondescript accent. So it's not that difficult to understand me. You have, thousands of hours of my speeches already. So you've got a lot of data to work from. You have a pretty good idea of what I'm going to say, because in my speeches, I often say the same things. I kept giving you reasons why this may not be as hard a task. And the teams worked really hard, both in China and the US. They actually worked on this pretty hard. A couple of years after I sent the memo out, they thought they'd gotten things to a point where they could make a go of it, right? So they came to my office. I tried this system out. We experimented with it on stage in China. And it just didn't work. I mean, it kind of worked, right? But the problem was it would make mistakes that seemed really crazy. And I said, look, I don't want to be the Microsoft executive who gets translated into saying some offensive thing, in Chinese. This is not going to work for me. And the team was very disappointed, but I said, look, it's not ready. We're not going to do it. But they kept working on it, and they they started incorporating new ideas and new technologies, right? So this is when we began to bring forward the notion of using these deep neural networks, and working with people like Jeffrey Hinton and some of his team in trying to adapt deep neural networks to this particular task. And some of that was the actual network technology. A lot of it was actually the technology for training the models, because it was painfully slow to train these models. So they had to develop both techniques for using graphics cards of the day to accelerate the training, but also to develop networking technologies so they could get large numbers of machines simultaneously working on the models. So they could reduce the training time from like 6 months to weeks, right? Which is an important part of this. They came to my office with their new version, and I knew things were great when we'd accidentally left the system on and we were just chatting, and it was transcribing everything we said. And it was incredibly accurate. I said, okay, this is looking really promising. So I went on stage in China, and as I said, I you know uh, spoke some amount of my speech in English. It got translated into Chinese, and they'd gone the second step of making the Chinese sound like me, right? Using my voice to help modulate it, and it was just it was tremendously influential. It basically proved that you could do this, and I think it empowered not just researchers in Microsoft and product teams at Microsoft, but also researchers around the world. It was exciting. I mean, I must admit, even from my perspective, I didn't cry on stage, but there's an energy when you create something new and you're able to demonstrate it for the first time, and you can see the audience visibly affected by it. There's an energy that goes with that, and and excitement, and I've luckily had that experience a number of times in the past for things that I've done. What I've always been excited by is just trying to think of things that are new, right? Just constantly learning about new ideas and new technologies. Really trying to push myself, to think about, what might, is this an idea that might make sense or not? And, I can't predict 20 years from now. I can't predict, the long-term future. Certainly, I mean, what you're seeing now are things that if you'd asked me 5 or 6 years ago, I would have said we would be making strong progress in, because we're seeing the fruition now of a lot of ideas and technologies that were in the research labs back then. So in that sense, I think you can make some predictions about where you might be going based on where you are. We're clearly having a tremendous impact on our ability to create, and whether that's artistic creation, whether that's technical creation and engineering, we're biology, whether create new medical techniques in the next 25 years. If you just think about what things were like 25 years ago. I mean, the World Wide Web, we just don't have any notion of where the technology was going to go, and yet it has changed everybody's lives. So I can't predict the future, but it's going to be great. Probably the single biggest legacy is Microsoft Research. I mean, in some sense, you create an organization, you hope that it continues on, with the same set of values and the same perspectives. And certainly, one of the things I find gratifying is when I meet with now older but originally very young researchers that I work with, who Well, tell me, look, you had a tremendous impact on my career. You changed the way I thought about what I was doing, and then they in turn have an impact on the young researchers that they work with, right? And it's that sort of, generational passing of perspective and knowledge that you hope, will continue and have an influence. To be honest, I think the Microsoft we have today exists because of the investments we made in basic research. So you could argue, in some sense, part of that legacy is the company itself, as it exists today, and its willingness to embrace change. I think the early founders, the early executives, they were, I think, important in helping to make those decisions and to embrace change. But it's something you have to continue to do. And I think having a research organization is one way to help push you to do that.